Good morning. Hi, folks, and welcome to What's New in Android Wear. My name is David Singleton, and I lead the Wear team globally. It's been a really busy year for us, and I'm really excited to be able to share some updates on Android Wear 2.0, and also some of the new watches that are coming later this year with you today. So even before the Android Wear 2.0 launch, we were seeing really nice momentum in this market. During the holiday period last year, we saw 72% growth in new devices activated compared to the year before. And since the launch of Android Wear, we've always said that people should be able to wear what they want. And part of this is the choice that users have between a host of different designs and styles of watch. And we can only deliver that through partnerships with iconic brands. The number of brands supporting Android Wear doubled from 12 last year to 24 this year. And the choice of Android Wear watches has doubled from 23 last year to 46 this year. And we've seen continued support from our consumer electronics partners, and now they're joined by their fashion counterparts. And this means that whatever your style, our partners have a watch for you. For example, TAG Heuer have updated their lineup with the connected Modular 45. It's a really innovative hardware design, which means that you can change everything from the horns to the bracelet and the clasp. Another partner that's refreshing their lineup this year is Michael Kors, with their new Access Grayson for men and Access Sophie for women. I love these watches. They've done a really nice job with the design, and with watch faces, including one that lets you put Instagram photos right there to see throughout the day. As well as existing partners, we're also welcoming a bunch of new partners this year, and we're excited to see partners like Movado, one of the most iconic watch brands, bringing their trademark minimalist design to Android Wear. Aside from watch hardware, we're seeing app developers, like many of you in the room and on the live stream, take full advantage of Android Wear 2.0. We know that people love to stay connected while they're out and about via their Android Wear watches. And our partner Telegram is taking full advantage of the standalone functionality in Wear 2.0. Not only does the app work the same way if you're connected to an Android phone or an iPhone, but when your watch is a cellular connection, it even works without the phone. And so sending stickers, like you can see in this little video, to your friends has never been easier. Another great experience made possible by the rich display on Android Wear watches is getting coaching while you're working out. So let's take a look at this app from our partner 7 Minutes Workout. This app's really great. I really love using it. It guides you through 12 30-second long exercises, and you don't need any fancy equipment, just a wall, a chair, and your Android Wear watch, and you can use it to stay fit and healthy. Another feature that we added to Wear 2.0 is the ability to have complication support. So users can now select the watch face that they love the look of and have the important information that they care about available at a glance throughout the day. Here you can see Robinhood, the financial investments app, is showing your overall portfolio's value right there on the watch face. And tapping on that, if it's maybe changed in an interesting way, takes you to their watch list. You can then tap on individual stocks to see their current value and the trend over time. So we see that the best Android Wear apps really focus on users' needs and what they care about, and then play to the strengths of the wearable form factor, as you can see here. As part of the Wear 2.0 launch, we also announced that the Google Assistant is now available right on your wrist. You can find answers and get things done by starting a conversation with Google. And we have some new features here. So for instance, you can now long press on the crown on your watch and say, send a WhatsApp message to Felicity, who's my wife. And the assistant will deal with the interface presentation, message dictation, and deliver to WhatsApp just the data that it needs to complete that action. So we're testing this functionality right now with selected partner apps, and it's going to be open to all actions on Google developers in the coming months. In the meantime, if you can't wait to get started, you can develop your actions for the Google Home and the phone today, and your actions will automatically be adopted for Wear when Actions on Google is enabled for Android Wear coming soon. No additional work is going to be required. And that means that going forward, as well as notifications, watch faces, and native apps, you have another option to bring your service to Android Wear. And we're super excited about the new capabilities that this is going to bring. So in the rest of this talk, Jen from our user experience design team will give you an update on material design and what we're doing to make designing and developing on Android Wear easier. After that, Griff will highlight some of the Android O features that are of particular interest to Android Wear developers. And finally, Nancy will talk about power and what you can do to conserve battery. So with that, I'd love to hand it over to Jen.
All right, hi everyone. I'm Jen, and I lead user research for Android Wear. So today I'm going to talk to you about some of the changes that we've made to Wear 2.0 as a result of research and feedback that we've received over the past year. So I'll go over some design guidelines, some common pitfalls, and how we're working on improving the developer experience. To start off, I just want to say thank you so much for all of the feedback that you guys have given us over the past year on the Android Wear developer preview. So we've made many improvements to the platform as a direct result of your feedback, like bringing back theater mode and swipe to go back. So thank you. Thank you. OK, so today I'm going to cover 3 topics: watch face complications, Android Wear UI design, and developer feedback. All right, so first let's talk about complications. So a quick refresh of terminology. A complication is a piece of information on the watch face that tells the user something other than the time. So like these highlighted bits here. So last year at Google I/O, we introduced new APIs to help developers build complications. So they enable any app to supply information to be displayed on the watch face, and they also allow any watch face to be able to present that information to the user in a way that fits its style. So we found in user research that people really like complications. They like being able to choose the data that they want to see at a glance and which actions they want to perform quickly. So here's a series of watch faces from one of our user studies. Now these are actual screenshots of watch faces that participants had set up after they'd been using their watches for a week. So we didn't give them any instructions on how to set up their watch faces. They customized these all on their own. And I'll point out a couple of interesting examples. So in this watch face on the bottom, the user wanted quick access to their music, so they set a complication to launch the Google Play Music app. And in this complication on the top, the user wanted quick access to their schedule, so they've got a complication to show the name of their next meeting, one to show the time of their next meeting, and one to show their unread notification count. So in user research, we also learned something that frustrates users. And that's watch faces that look like they have complications, but the data is actually not editable. So users quickly become used to being able to change the data on the watch faces to be whatever they want. So if you're a watch face creator, then don't just display a static set of information on your watch face. Adopt the Android Wear Complication API to let your users choose the data that they want to see. And if you're an app developer, then think about what information that your app provides that users might want to see at a glance. All right, so we learned that complications are great, and users love them. So why haven't all watch face creators implemented them? The answer that we hear from you is that it's hard, especially if you're implementing everything from scratch. So watch face developers have the freedom to draw complications however they want, but that means they have to handle everything themselves, including the text size, position, style, and layout. So to make it easier, we've added 2 components to the wearable support library. Text renderer, which auto-resizes text to fit the area that you specify, and complication drawable, which goes one step further and completely renders the complications for you if you tell us the location, style, and size that you want. Yay. All right. And one other thing that makes it really difficult to create complications is implementing the configuration screen, like this one that you see here, which can show the user exactly where the complication is laid out on the watch face and all of the different things that they can customize. So to help you implement this part, we've created a watch face setting example hosted on GitHub that you can take and easily adopt to change however you want it to be. And after coding, then comes testing. And so to help you with that, we've created an open source test suite data provider. So this makes it easy to check that all types of data are going to look good on your complication, on your watch face. And you can, since it's open source, you can also supply your own data if you want to test for a specific use case. And if you want to find out more about all of these tools, then go to the Android Wear UI session tomorrow, where one of our lead engineers, Ollie, will talk about the complications API and walk you through a bunch of these tools. There it is. All right, so the second topic I want to talk to you about is Android Wear app design. So last year, we introduced a number of new UI patterns as part of the Android Wear 2.0 developer preview. So we've learned a lot from your feedback in the past year, and we've updated the guidelines on when to use certain features and when not to. So for example, take the wearable navigation drawer. So this should be used for infrequent context changes, like accessing settings, logging out, or switching users. If your app has a small number of discrete functions, however, then instead of using the navigation drawer, it might be better to use multiple app launchers. So say you have a fitness app that has two discrete functions, activity tracking and historical analysis. So you can put these functionalities under two different launcher icons. And so another question that we get asked a lot is, how many launcher icons can you have? The answer is as few as possible, but as a rule of thumb, we'd say no more than 3. And in addition to those updates on the material design spec, we're also launching 2 things to help both designers and developers build wearable apps. For designers, we're providing a sticker sheet on the spec site. Sticker sheet on the spec site, sorry. Definitely utilize this, because not only will it help you make your app Wear native, but it's also much easier to try out different layouts and designs in something like Sketch rather than in code. And for developers, we're starting the journey to open source the Android Wear UI library. What this means is you can expect 3 things: consistent and stable APIs, frequent releases, and better responsiveness to feedback. And if you want to find out more, please go to Aga's session tomorrow on Android Wear UI. And yes, this is the same session where Ollie will be talking about complications. And last but not least, I want to mention developer feedback. So in the past year and a half, we've periodically sent surveys to the Wear developer community, trying to identify the top pain points to developing apps for Wear. And so as a result of that feedback, we've made improvements to the emulator, we've simplified the API, like in the work we've done with complications and the UI library, and we've adapted more examples into the developer guide to help developers get up and running on their projects. And so we want to continue to make improvements to the developer experience. So if you have any suggestions on what we can do better, then please file a feature request, and we will get on it. And thank you again for all of your feedback thus far. And with that, I will hand it over to Griff.
Hi, I'm Griff Hazen. I'm a software engineer and tech lead on Wear's developer platform. I'm here to showcase a few of the new Android platform features of particular interest to Wear developers. But first, I have a general Wear developer announcement. Earlier this year, we launched the Play Store for Wear as part of Wear 2.0. It allows you to search for and install apps directly on the watch. We also automatically suggest apps to install if the user has them on their phone, if they also have a Wear version. Developers upload their watch app to the Play Developer Console just like phone apps. The same app can include watch, phone, or APKs from other form factors at the same time using the multi-APK feature. When the user installs an app on their device, Play Store will automatically select the right APK to download. This works great on Wear 2.0, but if your app also supports Wear 1.0, it can get complicated. The old way to do this for Wear 1.0 required the developer to embed their wearable app within their phone app. When the user installed the phone app, the wearable app was extracted and sent to the Wear 1.0 device. This setup caused a number of complications, including increased phone APK size and a coupled release process. I'm happy to announce that we're starting to roll out a new way to distribute, improved way to distribute your app for Wear 1.0. The new flow, coming soon, uses multi-APK. It allows you to distribute your Wear app the same way for both Wear 1.0 and Wear 2.0. When a user installs your phone app, if you have a compatible Wear app in the Play Store, it will automatically be installed on Wear 1.0. This feature is currently being tested with a few apps. We'll be opening it up to all third-party developers. You'll soon be able to stop embedding your Wear app within your phone app. If you're developing for Wear 2.0 already, you'll want to make sure that your app works well on Wear 1.0 if you set a low minimum SDK level. All right, now back to my main topic, which is Android O and Wear. The What's New in Android talk yesterday covered many of the updates to the Android platform for Android O. Android O also has a lot to offer Wear developers, and I'll showcase a few of particular interest: notifications, auto-sizing text view, and background limits. First, notifications. Notifications posted by phone and watch apps continue to be a cornerstone feature of Wear. Android O has added a few new APIs to make it easier for users and developers to control them. The most prominent one is notification channels. Notification channels is a new API to organize notifications of the same type so they can be controlled by the user together. All notifications in a channel share the same behavior when posted, like vibration, interruption level, etc. On an Android O phone, when the user long presses a notification, they can quickly toggle future notifications from just that channel. They can also tap to get to the full notification settings for that app, where they can control other channels and notification behaviors. Starting with Android O, all notifications need to be posted to a channel. Here's an example for setting one up. First, create a notification channel object and provide a unique ID, a user-visible channel name, and an initial importance level. Next, set some optional properties like a vibration pattern and description, and call create notification channel to create the channel. Once this is done, you can start posting notifications with that channel ID. The Android Wear SDK for O does not yet include a settings UI for channels, but the APIs are available now for testing, and we'll be providing updates in future previews. The next feature I'd like to cover is an update to Android's text view control to support the automatic sizing of text. Android Wear devices have small screens, and real estate and readability are important considerations. With user-provided or localized text, it takes extra care to make sure the content fits well on the screen and is readable. In Android O in the support library, TextView has a new feature that allows it to automatically select its text size to fill the available space. The screens above show the same TextView layout, adapting based on the contained text. This API includes two ways to control this behavior. The first is to provide a minimum and maximum text size, and TextView will select a size within that range. The second is to provide a list of preset sizes. Here's an example using the list of preset sizes in XML. To turn on auto-sizing, first set the new auto-size text type property to uniform. Then provide the presets by setting the auto-size presets sizes property to an array of text sizes. Both methods can be configured in XML or programmatically, and also previewed in Android Studio. The support library has been updated to include compatibility on older versions of Android, including all Wear versions, so you can start using this in your apps today. My final topic is background limits. As our next speaker, Nancy, will detail shortly, preserving battery life is one of the most important considerations when developing a Wear app. We all want to create responsive and useful apps, but also make sure that the device can last through the day. Android O brings with it a number of platform changes to help accomplish this. Android allows apps to run and respond to events in the background. But when too many apps are running or execute for too long, it can overly consume limited resources like RAM and battery. Background services in apps targeting Android O have new limitations on how long and when they can execute. In general, if an app no longer has a foreground activity or service running, it will be considered idle, at which point all of its services are stopped. in past versions of Android, an app could also register for implicit broadcasts in its Android manifest. This made it a bit too easy for many processes to spin up for common events. This is no longer supported in general, but your app can still register for these events at runtime. A few best practices to preserve app functionality. The job scheduler and alarm manager APIs can still be used to run background work at appropriate times. There's also a new class in the support library, the job intent service, which uses job scheduler on Android O and a fallback to just regular services on older platforms. When your app receives a Firebase Cloud message, it will also have a window of time to execute before being considered idle. And if you really need to run, you can start your service in the foreground. A notification will be displayed to the user while it is running. Receiving location updates in background apps is another area where there is a behavior change in Android O. It was found to be a major contributor to power issues, with background apps being allowed to register for high rates of updates. In Android O, background services are now limited to receiving a few location updates per hour instead of having unlimited access. As a best practice, you can switch your app to use the batch location API. Your app will still receive location updates at a reduced rate, but each update can contain multiple location events. If your app needs to continue receiving a high rate of updates, for example, it's a fitness app and you're doing a run, it can start a foreground service and continue getting the faster rate. This is a brief look at a few Android O features relevant to Wear. There are more detailed talks available. For example, the background check talk by Ben Poise, and there's a notification talk this afternoon at 4:30 p.m. If you'd like to try some of these APIs on a watch form factor, the Android O developer preview has been updated to include a new version of the Android Wear emulator. Thank you. And with that, I'll hand over to Nancy to talk about Power.
Thank you, Griff. So hi, everyone. My name is Nancy, and I'm a software engineer and tech lead of the Wear Power team. So over the last year, the Android Wear team has been doubling down on improving the battery life of the Android Wear platform. And we've developed a set of best practices that we'd like to share with you today that can help you improve the battery life of your Wear app. To get started, I'd like to give you a sense of how much battery we have to work with on the watch. So here is a representation of battery capacity on the Pixel XL and Pixel phones. Now compare that to two of our recently launched watches, the LG Watch Sport and Style. As you can see here, our watch batteries are about 1/10 the battery capacity of their phone counterparts. So that's really not a lot of battery we have to work with here. But despite this, Wear users expect their watch to last all day long because oftentimes having a dead watch on your wrist can be worse than having a dead phone in your pocket or your purse. But what are some of the things that use battery on your watch? Well, one of the key drivers is the display. Now, on Android Wear watches, we have a lot of different types of displays. But for the next couple of slides, I'm going to focus on an OLED display as an example. Now, here we have the power draw when the display is off. Compare that to an always-on display. And again, compare that to an interactive display. As you can see, with each step, the power draw increases substantially. And that means that the battery life will decrease. So the takeaway here is that reducing interactive display time will save power. One way to do this is to reduce the amount of time that the user has to spend in your app by making it quick and easy for the user to do what they need and move on with their day. But sometimes you might need to continuously show information to the user. And in those cases, you should implement ambient mode. So in ambient mode, you should switch your UI to a black and white color theme and only update the display once a minute. And this will allow the application processor to go to sleep in between and conserve power. Another thing you should consider is using dark themes. Now, in our experiments, we noticed that an all-white display can use up to 7 times more power than an all-black display in interactive mode. And so if you're writing a watch face or an app where you expect a lot of user interaction time, you should switch to using a dark theme. Now, aside from just color, animations are also very expensive. Now, remember that display power chart from a few slides ago? Here's how it looks with animation power usage in the mix. Now, before you panic, remember that most animations only last fractions of a second, and so aren't usually cause for concern. It's a different story, however, if you're working with a long-running animation, such as a loading spinner. This is why in Where 2.0, we switched our framework loading spinner from the one on the left to the one on the right. The difference here is that we're only rendering 1 out of every 3 seconds in our low-power spinner. And just by doing this, we saw a 3x power improvement. So if you use the default framework spinner on Where, you will also get these battery savings, which you should do. Another example of animations is with the watch face. Watch faces that have a sweeping second hand, like the one on the left, uses substantially more power than watch faces that use a ticking second hand. So if a ticking second hand works with your watch face stylistically, you should stick with that one to save power. Aside from the display, another major battery hog is network usage. So perhaps the biggest battery issue that we have on Wear devices today is unnecessary background syncing. Now let me give you an example of an anti-pattern that could happen. An app could be periodically sending data between the watch and the phone or the cloud. Periodically, let's say every 15 minutes. When the user is not actively using your app, there should be no reason for your app to be syncing periodically in the background. The only exception to this is if you need to alert the user of something like a message or a notification. And in those cases, you should use FCM push notifications. Having said that, if you really can't avoid background syncing, you should at least try to batch your data. And we could recommend batching to transfer once per day, and preferably when the watch is on the charger. And you can do this using the Job Scheduler API. Now, I've talked a lot about network usage, but you might be wondering, how much of an impact is it on the battery, really? Well, I'm glad you asked. Assume you want to transfer 10,000 1-kilobyte chunks of data throughout a user's day. If you do this in one batch, in one 10-megabyte batch once per day, you'll use about 1% of the user's battery, which is OK. But if you do not batch this data and send this in 10,000 separate batches, you will end up using over 100% of the battery on certain devices. So the difference is night and day. So always batch your data. Now, another scenario I want to discuss is if you have to transfer a large chunk of data. An example might be if the user wants to download some music, or if they want to download an app from the Play Store, for example. If you are transferring more than a few megabytes, you should use a high bandwidth network, such as Wi-Fi or cellular. here's an example of the cost of transferring data over different radios. We have here Wi-Fi, cellular, and Bluetooth. So with the 1 megabyte case, the difference is not so huge. But let's look at what happens if we're transferring 30 megabytes. As you can see, Bluetooth is much more power intensive than Wi-Fi or cellular. So to transfer data over Wi-Fi or cellular, you can use the Network Request API shown here. Unlike on phones, starting in Wear 2.0, using this API will actually turn on these radios if they're not already on. And of course, there is a cost to turning on radios. So you should only do this if you're transferring a large chunk of data. In your network request, you should include a network callback. And once a network that meets your needs is available, you should get a callback and bind to the network that was provided. And then you can make your data transfer there. And when you're done, don't forget to release your network request. This will allow the framework to turn off these radios to conserve power. So for more examples of how to use the Network Request API, you can visit our developer guide by searching for Android Wear Networking. Now, aside from the display and the radio, there are also other expensive features on the watch that you might be using, such as vibration, location, and music. Now, I don't have time to go into all of these today, but just remember to use these features sparingly because they're very expensive. Also, if you want to debug your app further and look at how your app is doing on battery life, you might want to try out Battery Historian. You might have seen previous I/O talks about how to use Battery Historian to debug your phone bug reports for power. As you might have guessed, Battery Historian also works great on Android Wear. So give it a go and let us know what you think. Now, I want to mention one more thing. In many cases where we're seeing a user not get a full day of battery usage, it's often caused by an app doing some background network processing or location processing overly aggressively. This is why in future versions of Android Wear, we're planning to put further process restrictions on background processes and watch faces. This is in addition to the Android O background restrictions that Griff mentioned earlier in the talk. And so to prepare for this, you should make sure to implement the best practices that I mentioned here today to get ahead of the game. And always remember to test your app before you launch it. So we talked about a lot of things today, and just to give a quick recap, watches have tiny batteries, 1/10 of phones. Displays are expensive, so try to reduce interactive display time, implement ambient mode, use dark color themes, and reduce animation usage. You should also be careful with network and make sure to avoid background syncs, to batch your data, and to use high bandwidth networks for large data transfers. And finally, don't forget to try out Battery Historian for Wear. And with that, I'll hand it over to David to wrap us up.
Thank you, Nancy. So to recap, we're making complications and Wear user interfaces much easier to build, so there's no better time to get started. Second, as part of the Android family, we're getting a whole host of new features from Android O, so be sure to check those out and test your app, especially the background limits. And finally, battery is really precious, so please conserve it using the tips that Nancy presented. Apart from this session, we have 2 more sessions on Android Wear at Google I/O. So firstly, we're hosting office hours at 5:30 p.m. today, where you can ask experts from the team anything about the issues that you face or the opportunities that you see while designing or developing for Android Wear. And second, we have that other session that Jen already mentioned tomorrow, focusing on the new UI tools we talked about today. And we'll go through in more detail the new simpler complications rendering system that you can start to use if you would like to, as well as the new Wear UI library that we're open sourcing. Thanks for attending this talk. And if you have any questions, the presenters will be over in our sandbox right after the talk, and we'd love to talk to you then. The sandbox is where you can see right on this map. Thank you very much.